let's start with administrative stuff. As far as scribe goes, I can scribe for today. And yeah, if I'll happen to. Oh, and here's Andrew as well. So I can scribe for today. As far as the next call goes, I think that we. Let me open up my calendar, and I think that the next call is planned for May 16th, so 2 weeks from now. May 16th at 11 a.m. PST. Does that work for everyone?
I'm out that week.
Okay, so the entire week?
Ryosuke,
Yeah, sorry.
We'll assume that it's okay.
I'm sorry, what?
Sorry, I was saying, other than Ryosuke not being able to make it, any other conflicts for folks? Would 16th be okay? Not hearing loud objections, so I guess we'll go with that.
Okay, let's go with that.
Can we have an update on the face-to-face meeting?
Yes. So it's currently planned for the week of June 10th. We are not, I don't yet have confirmation on the venue, so I wasn't, that's the reason I didn't send an update to the list. I will hopefully have confirmation on that very shortly, and we'll update the list as soon as I possibly can.
Can you please send out a notification to the list that we are currently planning on that week, but still locking down so that everybody's aware, even the folks that aren't on the call?
Sure.
Thanks.
And we targeting the San Francisco area?
Yes. Either San Francisco or the Bay Area, it's still unclear. Okay, and otherwise, I think we can get started with mean thread scheduling. Shubi I haven't seen Scott. Scott,
I'm here.
He's here. Yeah, I can give a quick intro. So Scott basically is on my team working on scheduling. So he's sort of driving the API work now, and I think over the next couple of design meetings leading up to the F2F, we just wanted to kind of start introducing pieces of where our thinking is. So just starting with a first nugget. So we don't want to pile on the entire proposal in one short. So just starting with some of the underlying concepts as a starting point. Just start. Scott, feel free to take it away.
Okay. Thanks, Shubi. So the kind of the goal of this is to talk about what we're working on for native scheduling API, and particular the big underlying problem that we're trying to solve here. It's not the only problem, there are more, but we'll kind of get into that. And just give everybody an update and share progress, Q2 plan, and kind of where we're going with this. So to start, there are two claims that motivate what we're building here for an MVP v0. And everything that I'm going to kind of talk about today is all around this notion of priority. So user space schedulers, like React, Maps, other schedulers that have been built into user space are limited by their boundaries. What I mean is that they have a notion of priority within their scheduler, but it's scoped, it's limited. It can't escape out of that boundary. So in the case where they aren't sharing a common framework, it's limited to one particular app or a particular framework, but not shared between app and framework. In the case where they share a common framework, it's still limited in user space in general. It doesn't escape into the browser. And at the same time, browser schedulers like Blink Scheduler is limited by the lack of knowledge of user space priorities. And what this means is that there's only so much it can do with regard to scheduling with a bit of information. And the model that I'll show here in a couple slides will illustrate this. So a native scheduler, in the part that I'm working on, compared to low-level APIs, what we're trying to do is give the browser control over scheduling. So low-level APIs, the goal is input pending, and some of the other ones that we've been discussing, give apps better mechanisms to do better scheduling, right? But what we're trying to do is bring some of that into the browser. It still results in better scheduling, but it gives the browser more control. And the browser has a good vantage point at this because it sees everything. So it's able to coordinate scheduling across multiple entities that share the page between user space script that's scheduled via a post-task API and other async work that needs to get scheduled for the completion. And how we do this is through a shared notion of priority. So looking at our current model, and this is what's going to kind of illustrate the problem here, is we have this essentially this priority system, and this is for an individual document. So some of this is going to be a little bit Blink specific, but I think it generalizes to browser scheduling in general. So at the highest level, we have input. We schedule that at the highest priority. It runs as soon as it can. At the very bottom of this list, we have idle, like request idle callback, which runs only when there's nothing else to run. Now, in between, there's rendering, and most of the time this is prioritized, but the spec gives leeway here. If there's a rendering opportunity, render, right? So that we might want to throttle this if rendering is taking too long or it's happening too often, that kind of thing. But really what I'm focused on is this number 3, this big chunk, a blob of everything else. And this includes script, like post message and set timeout, fetch completions, IDB completions, script tag parsing, HTML parsing, internal work that the browser needs to do, garbage collection, et cetera, et cetera. So there's a really big list here, and what happens is we schedule this basically as one big FIFO. In Blink, we have multiple tasks.
I'd add though, this model only works for Blink, right? I mean, WebKit, for example, doesn't prioritize input beyond rendering or post message at all. That's not a thing.
Yeah, I think I said that some of this is going to be Blink specific. I'm not entirely sure, and I'd love to hear how exactly you do scheduling, but I'm not aware. As far as the big blob everything else, do you actually prioritize different things, or does everything run first in, first out?
I think Ryosuke is saying that they do even less prioritization.
Okay.
But feel free to maybe after the presentation we can talk a little bit about how WebKit does this. That would definitely be enlightening.
Sure, but at least for Blink, this is what we have, and yeah, if you're saying some browsers have even less prioritization, that just exacerbates the problem. So, and what I'm saying in Blink, we do have multiple task queues, and the spec does give us leeway to schedule between different task queues. But for a single document, it's one logical task queue. Things run in first in, first out. So I want to zoom in a little bit on this bucket and talk about how user space schedules work. So React Scheduler, for instance, uses post message to run its tasks. And within the React Scheduler task, there's a notion of priority. So each of these tasks that you see here would be prioritized, and it runs them in a specific order. But to my point in the motivation, these priorities are meaningless outside of this box. They can't be interleaved with other work such as on ready state change, on success, different async callbacks, script processing, any of that, because the browser scheduler doesn't know anything about their relative priorities. So for the MVP, this is kind of what we've identified as a problem that we want to work on and try to solve. So there are, as I mentioned at the beginning, there are other problems as well. There's a lack of a unified API. We have disparate scheduling APIs, idle callback, request animation frame. We don't have a unified API service here that makes scheduling easier. So that's something else we want to address. When to schedule frames. There's been talk of frame rate APIs. some of this is Blink specific from the last talk, but Blink frame, how we schedule frames is something we want to work on. Clean reads, how to do like the fast DOM pattern is something else that is kind of on our radar as well. But for a lot of this, what we need is a core priority framework to build on top of. So what I'd like to do is introduce a new web scheduling model, one that actually has priorities. So the requirements here would be a unified set of priorities. And this is the benefit of a native scheduler. This allows scheduling not just within an app, but across the entire system. We need priorities that are above and below the existing default or everything else priority, which is just necessary for a scheduler to operate. And this last point, again, was a little more Blink specific, but it can apply to other browsers too. We still want a separation of scheduling API priorities from what happens internally. And the point here is that you may have multiple documents sharing the same thread, the main thread, and if you have a lower priority frame, for example, a background page, then high priority in a background page may not be high priority overall. So this is the point here, is something that we're considering as we build this API. So what we're proposing for a model is to introduce new priorities. And this is what we're planning to experiment with. What we want to do is break the everything else up into levels below and above. So we'd introduce a high and a low priority that's around default, with existing work getting scheduled at the default priority. We have a level above input or rendering, a high event, or immediate, not quite micro task timing, and we're still kind of working out some of the details, but it's something that runs as soon as possible, and this is for urgent rendering, that like render work that needs to be done but prior to rendering for the current frame. There's also a use case for something below rendering but above a high priority, which would be used for something like input handlers. We're still kind of, again, a lot of this is still preliminary and we're working out the details here, but we've seen cases where, like React, for example, they want to process input right away, but they also want to yield to rendering to keep animation smooth. So there's a use case for having a priority that could, a very high priority that's below rendering, but is only allowed to be used by input handlers. So that's something else we're planning to explore. There are a significant number of challenges when talking about building a system like this. There's a link at the end for the next few slides. There is a very in-depth document that's linked at the end that goes through in much more detail this, but this would be a whole another topic for a deep dive. But there's kind of three big questions here. And one is, what do we want to prioritize? There's a lot of tasks that run. The scope of scheduling is huge. We have user space script like post message, set timeout, those types of things. We have async completions, script HTML parsing. We have further down the line the browser side scheduling for fetch and things like that, network scheduling. We have microtasks. So there's a lot of different things that we can prioritize that expands the scope here. There's a really big question around which priority system we use. So for those that aren't familiar, there's two basic types of priority systems in scheduling. There's for priority-based scheduling, there's a static or fixed, where you always run things in priority order from highest to lowest. And then there's dynamic, where priorities can change over time. And the problem with a static system is that you can starve out lower priority work. So throughout the history of scheduling, there's been many such systems that have been built that address this in different ways, but it's usually based on application specifics. So for example, Maps uses static, that works very well for them. React uses the earliest deadline first, and then there are others as well. There's another question over how much isolation and control we give the browser over scheduling. And there are several models here that give varying degrees of control. Again, there's a deep dive document attached at the end here that you can take a look at, but just as a kind of example of what I'm talking about is you could design a system where there's a single set of global task queues. Everything is posted to these task queues. Everything has the same exact priority system, and scheduling is rather trivial in that case. Or you could design a system that is a little bit more isolated, where maybe app code has its own set of task queues. Framework code has its own set of task queues. Third-party code has its own set of task queues, and they're isolated. So there's still a shared notion of priority, but this gives the browser control over how it schedules. So again, the challenge here is figuring out what the best model is to use. So to wrap up, what we're proposing to start with is the simplest of all of those. We want to use a single set of static priorities, the ones that was in a previous slide. The observation is that different apps have different requirements, and once you use dynamic, you're kind of forcing apps to adapt to that. It's not clear if it's always going to be the best fit. It's not clear which system generalizes. And we don't really understand to the degree that starvation is going to be a problem. So our plan here is to start simple and evaluate after the initial round of experiments. And we're also planning to start with the simplest model of a unified logical set of prioritized task queues. So the browser is not going to do any sort of fancy isolation type scheduling to begin with. Also for the MVP, didn't talk about this before, but there's another problem that happens in scheduling, that when you yield, so if we picture that one big FIFO model, if the task that's at the head is running and it decides to yield because it wants to give browser control to, say, render or to, say, process input or any higher priority work, if it reschedules itself, it's stuck at the end. And this can significantly impact latency of the app, and it incentivizes yielding in the first place. So we want to have some sort of continuation support built in that tasks can yield to higher priority work but continue. Also in the first version, we'd have delayed tasks, and we'd have implicit support for bulk operations. And if you're at all familiar with the original proposal, this is the idea of virtual task queues. So you could do things like flush a task queue or clear a task queue. So roadmap going forward for us, the next thing, so internally I have a proposal for the API. It's still kind of young. We're working through some of the specifics. We're going to get this out to partners and everyone else as soon as possible. So the plan is to publish the updated explainer as soon as we can, then start working on implementing this MVP behind a flag in Chrome, and have our partners, Maps, React, Airbnb specifically, start using this and get feedback. And then finally, a couple public docs that anybody can look at, and I invite you all to comment.
So I guess one thing I wanted to add that's relevant to the roadmap is that based on kind of both our data as well as what we keep hearing from our partners, we find that just creating a post-task-based API is kind of insufficient, given that the main thread is just like totally, often very congested with just script tags coming in and like fetch responses handling and XHRs coming back. So that's why we want to push on those fronts at the same time as the post-task, or I mean, as like creating this basic set of priorities, but they also have to interplay.
Right.
Maybe in a future session, we could talk more about that aspect.
Right, thanks. Yeah, I forgot to mention that we are actively focused for Q2 on integrating fetch and script tags with this as well.
Yeah, so at this point, I think what's most useful is hearing what kind of validation people would like to see in terms of, as we are working with Maps and Airbnb and various other parties, in terms of like getting them to start using something, like what questions would you like to get answered to, like, I guess, have more confidence that we're moving in the right direction.
From one slide, is that like we are solving, like there's a motivation slide. Was that space so it doesn't matter about the other framework or app scheduler and the blinkers node, but like that's not necessarily issue, right? What
Ryosuke, I think
what
you're
is
breaking
the
up.
actual user-facing issues we're trying to solve here? Like, it's unclear.
Okay, so
Sorry, what?
So your video was cutting off, so we didn't hear everything you said, but I think the gist of it is that which user-facing issues are we trying to solve?
Right.
So I think it's mostly about like juggling kind of priorities or like kind of these deadlines that apps, we've like thrown at them a bunch of deadlines. Like, oh, if you're like rendering search results, it should happen in 100 milliseconds, and it will make sure to break everything up so that you keep meeting the 10 millisecond target for frames, and like 10 millisecond targets for typing and keeping the user input responsive. At the same time, and then we've thrown a whole bunch of APIs at them that are graph, set timeout. Now, it's just really difficult for them to succeed at those deadlines, given the current set of APIs and the fact that the main thread is completely.
So is the goal? Yeah. So is the goal is to meet the user input responsiveness? Like app has received some input and they want to do work for the next frame. Is that the goal?
Yes, it's all of the deadlines. The 100 millisecond or whatever for input. The 10 millisecond for frame rendering and whatever stringent 10 millisecond for typing.
And decreasing latency overall. Like I guess like the point I was going to make here, and I didn't make it, is so FIFO gives you one order, right? It's somewhat random because it depends on the order in which things are, sometimes it depends on the order completions happen, like when network regrets come back, all of this. But there's a specific order that tasks run in, and latency, other metrics, user-facing experience metrics are dependent on the order in which these tasks run. And my claim is that the order that they're running in now is not optimal. And I'm not saying like scheduling will necessarily give you the optimal order, but it'll be a better order.
But ultimately, in what sense though? Like that's what I'm asking. Now, what are we trying to optimize here?
So user input, as well as like different types of user input. Like clicks have different expectations from like user typing and other type like. So there's different like timelines, deadlines that have to be met for different types of input, as well as
also, right?
Hmm?
Page load metrics also, like loading. There's a lot of stuff that happens early in load, some of which affects first contentful paint, things like that, and better ordering at the initial when there's a lot of work going on can help.
Yeah, for loading, I would say it's primarily about the first input delay and time to interactive. Like, and when the user's trying to interact with the page, but then all of like Webpack throws in a whole bunch of script tags that are really unprioritized, and it's really difficult to meet the user expectation. So yes, but ultimately it comes down to what the user expectation is, both for interaction jank as well as visual jank.
So Scott, I assume in the explainer we motivate or explain some of the use cases of like maps. I think you mentioned Airbnb as the first pilot customers that are really keen to experiment with this.
Yeah, so I did that in the original explainer, which I guess is all we have done so far. And so now we were more like kind of pushing on what are we actually working, like how are we solving that problem? But yes, the explainer should have motivated, or does right now, if you go to the GitHub link, which I will link from the agenda.
Yeah, I guess this is connected to Ryosuke's question and to your own question, just to bring it back, which is in order to validate like a clear explanation of what problem we're trying to solve, for example, through maps. Like, so if they must have an articulation of what specific problem they want to solve in Airbnb, right? Like, those would be the two concrete examples.
Yes, and React, Facebook is the third one.
Right. So if that's already covered in the explainer, then I guess we should take an AI for everyone on this call to read through that and maybe come back with feedback.
I'm sorry, can I just ask a quick question? I'm a little confused about when we're talking about defining what the user expects in this and what we're optimizing for the user. Are we optimizing for the user of the web application at the end, or the user as the developer of the web application to achieve their goal, helping the ultimate web user?
The latter. We're helping the web developer achieve the user expectation for interaction as well as like visual jankiness.
Okay, so our user is the developer, and when we say user, that's the user we're talking about. Thank you.
Also, sounds like really the criteria for deciding whether we have designed something good or not is that we need to have, like, sort of based on the case studies you have to create some testing scenario for each app, right? Like maybe initial page though, maybe, the user interaction time in some React app, and then measure that.
Yeah. So speaking on behalf of React, one of the main reasons we came up with isn't pending was because we wanted to do as much work as possible and maximize the throughput of like render tasks while still being able to yield to the browser and provide responsiveness. One of the success metrics we'd be looking for in a high-level scheduling API is that if we schedule our render tasks through the high-level scheduler, that we still get that input responsiveness we were looking for and that task throughput. So that could be a useful metric to track.
Yeah, so I think we can take a follow-up here for each of these three partners before we can like come up with specific scenarios that those particular people or apps care about, and what metrics they would use on there, because it's hard for us to kind of fabricate metrics for each of these cases, but that's why we're working so closely with them. So then we can like leverage their success metrics and their regression metrics.
Yeah, and I'm assuming that as part of the experimentation, they will also report back on their current success metrics and show that there are no regressions compared to their current userland scheduling, right?
Yes, absolutely.
Right.
So you're adding a different priority. How do you solve the priority inversion?
Do you have a specific example in mind?
I mean, if you have a priority, you're gonna have a priority inversion. Like you don't.
I mean,
we're not supporting that would just simply not work, right?
So
like you can read any literature of scheduling.
What I heard was, so the static list is going to be effectively like FIFO, and it's going to run in a declared order. It's going to be at the point at which dynamic scheduling starts to happen. That's when priority inversion can happen, because that's when. So I guess at some point in the future, it's believed that this scheduler will likely move towards dynamic to handle these types of cases. Is that?
Or at least dynamic will be an option. Like with static, I'm just thinking through your question here. I propose starting with static priorities. So the priority inversion that would happen if we're talking about high priority work getting stuck behind low priority work, it's only because there was no high priority work to run when we chose to run the low priority work. You can get other priority inversions, and in the long read doc that's referenced here, I do talk about priority inversion in the case of timeouts. If you have a lot of, like, if we were to, one option that we talked about is introducing a notion of timeout here, like request title callback has. The problem here is you can introduce priority inversions, and I was a little bit skeptical of introducing them for that reason, because if you have a lot of low priority work that all times out at the same time and you schedule high priority work, then it's now, the high priority work is now stuck behind all of those low priority works, creating that inversion. So I don't know if it's fair to say every time you have priorities, like, you necessarily have this same inversion problem. That's why I was asking for specific based on the proposal. I mean, you have priority inversion now. Like, you schedule something, everything is scheduled at the same priority, and what just got scheduled may be high priority, but it's stuck behind everything in the queue. So I don't know that I'm not sure how much worse this makes it.
I'm not saying it will make it worse, but
yeah.
I think that's the biggest problem, right? Like, if we don't solve a priority inversion problem, I don't know what problem we are solving here.
Mm.
Like, I mean, there are like many people who have talked to us and said, oh yeah, like, we want to change the priority of things dynamically because, you know, maybe we're doing the work on low priority because the user is not interacting with some widget for now, and then later it becomes important, right? Like a workflow like that, very common, and whenever that happens, like, all the user input is blocked on that whatever the previously low priority thing that, you know, maybe still waiting to happen.
Oh, yeah. There. I don't know if I probably didn't mention this here. We do have the MVP is including a way to change priorities, so you can, off of version 0, you can build dynamic priority systems in user space. So if you have low priority work that suddenly becomes high priority, you can change the priority.
So one example of this that comes up is like the maps use case. So on Google Maps, like, as when the user is scanning the map, it's really important. The highest priority thing is like fetching of those map tiles and preparing them for rendering. But then the user gesture can change to like dragging a drawer, and then like you want to deprioritize all the tile work. So I think Scott is what Scott is talking to would address that. Like, we need to provide a way for the developer to dynamically indicate what the highest priority thing is now. So Scott, I don't know if you want to get any more details to that aspect.
Can you repeat the last part?
Do you want to add any more details? Like, for example, the task queues, virtual task queues, and updating priorities.
Yeah, it's kind of a long the conversation, the roadmap that we're having here as far as like virtual task queues. But the idea, like with the virtual task queue, is that it's like a subset of the main task queue that is just for. Okay, let me back up. The V0, as far as changing priority goes, we're allowing you to move tasks between task queues. Okay, and if the priority is on each task queue, then if you move a task from low priority to high priority, then the task is now high priority. So you could create a periodic very high priority scheduling task that just updates priorities. And this takes care of changing the priorities of things that were low and now should be high. We're moving towards a model where you have this idea of virtual task queues. So user space script can maintain its own task queues of its own task and change the priorities of all of them at the same time. I guess, Ryosuke, to your point, like, I mean, I feel like this solves a lot of the problem of if you have these low priority things that are stuck behind high priority, getting them to be the high priority once it changes. The question is then going to be the task that changes that. You need some task to trigger that to happen.
Yeah, and it's just sort of hard to address that in the general case. That's why I think it might be nice if we could add a couple of scenarios in our explainer. So for example, the map tile gesture change, or like Facebook feed, you had things that were off screen and now like the highest priority thing. So we could like have a few different examples and show how the API handles those cases. Would that address?
So I think the general design. I mean, have you talked to people working on say like Android scheduler? I mean, the problem with that, if you have some sort of fixed set of priorities, what happens is everyone maybe claim high priority, and if you have no idea which ones are actually high priority, and relying on the users to keep adjusting the priorities based on everyone else's priorities is really tricky. The problem you don't know your existing in sort of system, right? Then what happened is that they don't know how like you as one of the users of scheduler, you don't know how high your priority is relative to everything else happening, right? Like everyone knows its own idea of what is high and what is low, but there's no coordination between them. So the way, for example, on iOS and macOS, the way you would address this problem is the concept of QoS, that specifies, for example, which thread is foreground, the user interactive, user initiated, right? User interactive is highest priority, and then followed by user initiated in the background thread, and so forth. And these threads dynamically adjust its priority based on whether containing applications are foreground or whether there's other user interactive, user initiated threads. And then there's another system called the vouchers, which gives the priority of the high thread, like it basically delegates the high priority work from high priority thread to low priority thread, and then low priority thread and therefore gets boosted its priority when it receives voucher. So there's a lot of, I mean, if you look at any schedulers in any modern operating system, there's a lot going on there to mitigate this problem of too many things having the same priority, and there's a lot of mechanisms to like sort of delegate the priority and then define the dependencies. And I think it really comes down to defining dependency. Like at the end of the day, the most efficient scheduler is knowing what is the dependent work that it needs to happen and it's important to run.
I suggest that because we still want to cover updates from Andrew related to the JavaScript profiling API, I suggest that those great discussions will be taken to the YCG repo. And yeah, any participation, any feedback there would be highly appreciated. Okay. And
yeah, that sounds good. I would definitely encourage people in this on the call to like feel free to file issues on YCG requesting more explanation on various parts of the project proposal, and we can prioritize those.
Just quick note, folks. We do need to move on to the next topic, but I think I saw Ben trying to jump in a few times. Ben, do you want to?
Yeah, I just wanted to say I really appreciate the context given by the Google Map panning example, because previously you had just talked about our data and our partners. So something concrete like the Google Maps panning fetch info was super helpful. I would love to see more of that developed in this, and I'm certainly I'm willing to file that issue. Thanks. That kind of additional context is super helpful. Thanks.
Awesome.
Thank you.
okay.
All right, let's move on to the next.
So Andrew, do you want to present or?
Yeah, sure. I've got a few slides here.
Also, before we move on, can I ask one thing? Which is that could you put the current whatever you had on the current slide into the GitHub page somewhere? Because now like document is outdated and it's really hard to follow what is currently being considered. So if you could update the GitHub page, that'd be great.
Yep.
You're actively working on that.
Okay.
Great.
everyone see that all right? Cool. So yeah, for some context here, Facebook has been working on a JavaScript profiling API so that you can understand like unique execution profiles in the wild better. And you can find more of that link there. We've been focusing a lot lately on making sure that we get down the cross-origin concerns. And through that, we've been like evaluating the feasibility of that approach via a Blink implementation. And so far, things are pretty good so far. We can get the incumbent realm from frames that are captured on the stack with the data that V8 provides us. And the cross-origin script situation can leverage a lot of the existing infrastructure. So today I'm going to mainly talk about like what are some like ambiguities and issues with the original proposal that we found when actually doing the implementation, and solicit some advice from you guys as to like what we should do next. So the main issues that we saw so far were first and foremost the issue of building a like symbolization map before you start profiling. So that's actually getting the data that you need to map like program counter offsets over to function names and source location information. This turned out to be fairly expensive since this is not done by default when you're just running an arbitrary script. This actually requires a built-up code map, mainly for performance and memory concerns. In the domain of trace format and sizes, they were around what we expected from our initial survey from Chrome tracing data. And lastly, I want to talk about the issue of web tests, which are a little bit challenging given that the original proposal does not mandate any kind of SLA for sampling, so that it's fairly intractable without a normative claim to figure out whether or not a given sample is correct if you're not guaranteed that you'll ever receive a sample from the API. Okay, so starting out on symbolization or symbolication, there's two main approaches that a VM could do with this. They could either always build up that code map while they're running JavaScript, but that's kind of not the best, considering that takes up memory and has extra like CPU time overhead. If we knew that profiling was always going to be performed, this might actually be a decent solution. If we decide to build up that code map lazily, this is a little bit problematic since it has to happen on the VM thread. Even though the original proposal for the JS profiling API actually allowed you to return a profiler async, that more often than not couldn't actually be done since it required a heap traversal in order to find all the code objects. So that makes it a little bit tricky since if we block on a heap operation on the main thread, then like potentially we could leak data on like the size of the heap if there's other frames inside of the event loop, and it's also very slow. On Facebook.com, doing this with V8's code map populator took around like 200 to 300 milliseconds with a full heap on a high-end machine, which is fairly unacceptable, considering that one of the main use cases for the profiler is instrumenting interaction. So the minute you, like instantly after you say, like you click on the notifications button, we wanted to be able to start profiling so we could figure out, okay, so what's exactly on the critical path from the like second you click it to when you see like your notifications.
And when you say high-end machine, that's a desktop machine?
That's a desktop machine, yeah.
Okay.
So not good. So yeah, as I said before, like building up that code map online as code is being compiled is awesome because then we could start up a profiler almost instantly. If we knew that we could profile, then this would be acceptable. Otherwise, like we really just don't want to slow down the web for anyone if you're not going to be profiling. So I was thinking about addressing this through feature policies, just declaring like a profiling feature policy. By default, it's disabled. If this feature policy is present, like startup will be super fast. The whole notion of feature policies being constricted to like certain frames fits kind of nicely with how we've defined the profiler to be context specific. And yeah, we won't have any kinds of, the main issue with this approach is primarily like I would say pretty significantly or increases the overhead to actually deploying this profiler on your site. So yeah, any feedback on using feature policies for determining this, or?
Andrew, I'm trying to understand the flow here. So you, as a site operator or I guess webmaster, would set the policy that would enable the
Maybe better to just use a header.
The profiler?
Yes. So it's just a header.
Why would you need to do that, or why is feature policy necessary instead of just like having some direct JavaScript way to invoke the profile?
So as I said, the main issue with that is that the operation that you need to build the code map actually must be performed synchronously. And that's a bit of a problem considering that could like leak information on the size of the JS heap.
Is that a Blink implementation detail? I guess I'm wondering if you had a completely different JavaScript engine and a different engine, would those limitations exist?
I talked with Marcus a little bit about this in the past. I forget what we decided on. Marcus, are you on the call?
Yes, I'm on the call. I don't know if, it probably is possible to write your JavaScript engine in such a way that this overhead is almost zero, but ours is not written in that way, as far as I know. Yeah, whenever we enable profiling in our built-in profiler, we tell the JavaScript engine to throw away all the JIT code and to start recompiling the functions and to build up a code map when it does that. So we would have the same problem.
Okay. I asked because I'm aware that Chakra, the previous Edge engine, could do this, and therefore it seems like artificial constraints, but I'm not sure that's a reason. So therefore, having feature policy for an artificial constraint seems odd.
I agree that feature policy is not really the place where I would have expected this. But
okay.
It does make sense to have a switch before any JS code for the website gets compiled. And the header would be such a place.
So we have discussed header-based registration for various performance entries in the past. And one of the reasons was if we had entries that were particularly expensive, we would want to only enable the collection of those entries in environments where they're needed. So this seems to fall into the same bucket. So I don't know if we need a feature policy or a different type of header-based registration. And if this falls under feature policies, it makes sense for the other header-based registrations to fall under the same bucket. And I'm not sure that we need the feature policy inheritance model here when it comes to frames and delegation of those of that profiling.
I think that the one potential difference here is that sometimes when we've been talking about header registration, you would actually kind of almost instantiate the performance observer via something in the header. Depends on the proposal. But here we're just saying you can measure this, not start measuring this right now, which feels maybe subtly different. But I think ideally we would be able to find a common way of reasoning about both cases.
Probably something to discuss in the future.
Okay.
And Andrew, you want to keep going?
Yep, sure. So I'll take a look at the other performance timing related headers. I'm not particularly married using feature policies here. I just figured that if we could leverage any existing infrastructure there, it would be useful. But a simple header is likely to be fine as well. Cool. Moving on to what we've gathered from the trace format so far. So for a quick recap, the trace format being used in the proposal is a trie format that coalesces common substacks as well as duplicated frames. And it's a form of structural compression fundamentally. And one of the big questions was like, do we actually need to add gzip or potentially like a binary format for this to make it more tractable to serve over the web? So from our initial data, we found that URIs were a super common source of redundancy. So that was some pretty low-hanging fruit there. So we added a resources table to the definition of the trace format, which reduced our trace sizes by around 30%. So it's pretty easy win for everyone there. There was some concern about whether or not gzip trace blobs would really be the way to go, since this is something that could be potentially polyfilled by the browser, linear in the number of samples, frames, and stacks. So if you just returned a gzip blob, it could be potentially problematic, since you might not actually need to use all the fields that the blob contains. Like in our case, for example, we don't necessarily care about function names, since all of our sources are minified, and many other sites are likely to face the same issue. So we wouldn't need to send that entirely. We could conceivably have a different approach where we provided like a list of like properties of samples that we wanted to get inside of a trace. Like some consumers might not care about timestamps. Some consumers might not care about like line and column data, for instance. And so we figured that just providing like a base JavaScript object format that is still in that structurally compressed format, while still being like mutable before sending to the server, might be the way to go.
Yeah, and in that context, we also talked in the past about gzip API in the browser. So I don't think the polyfill route is necessarily a viable one for most people. But that could be motivation to actually implement some gzip API, which is great for both this regular resource timing data and many other uses.
For sure, yeah. Right now, Facebook is using a WASM version of snappy compression to send payloads to the server, and we've actually had some pretty good success with that. Like, it's fairly low overhead. But obviously, like having a browser API for compression would be like great, and to let the case for resource timing as well is really good. So cool. So here's some data that we got from page load of the site. So this was around a 4-second trace of pretty much pure JavaScript execution, and the numbers are there. It was around 120 kilobytes raw, with like a sixth of that with gzip. That was at a 10 millisecond sample rate, executing a lot of unique functions and resources. What are people's thoughts on like this data? Like, is this around what people think is within the realms of viability for use cases, or is it kind of pushing the boundary of size to which we might actually want to consider like a more in-depth compression method?
This doesn't seem too scary.
I would say from a RUM analytics point of view, 22 kilobytes gzipped is we're on the top end of the payloads that we generally send out from the page. Raw, sending over 100 kilobytes out would definitely raise some eyebrows. So somewhere in between those would probably, be something that we can get away with without too much concern.
Cool.
Yeah. How did you pick the 10 millisecond sample rate? Like, you would still get significant value using 100 millisecond sample rate for a sufficiently large site, I guess.
Right. Yeah. So this is mostly just like a worst case scenario. Like Facebook.com already ships a ton of JavaScript, so this is worst case in much more ways than one. 10 milliseconds is generally like what we want to be the lowest supported sample rate, or the lowest reasonably supported sample rate at this time. So that's why. Cool. All right. Yeah. I guess moving on then. Lastly, I just wanted to talk quickly about testing the API. So as I said before, the spec doesn't really provide any guarantees as to whether or not like a sample will be taken within a given interval of time, mostly because the way that those samples are triggered really should be implementation specific, and those implementations for true sampling fashion are typically driven by timing sources or interrupts, which both can be like inconsistent depending on the system scheduler. Lots of scheduling problems today. So as a result of that, that's why we went with that non-normative issue. However, that does make it like fairly intractable to test. Like if you want to write a web platform test for this, say you run a profiler for like 2 seconds, you still could be guaranteed that you get nothing by the spec.
Yeah, you could introduce some WebDriver API that enables you to get more like, you know, even though it's non-standard, we'll be able to get some guarantees regarding the sampling rate for the testing scenario.
Okay, cool. That sounds kind of similar to my first point there, except putting in WebDriver for testing does seem like it might be more idiomatic.
Yeah, because you don't want to expose that to, like, in non-testing environments.
Right.
And Drew, I've got a question about that. You only get JavaScript level information. You don't get information on force layout or the browser garbage collection.
There's no data on browser internals exposed. It's just client JavaScript and first order like callbacks. So things like your set timeout call will be included, but nothing beyond that, obviously, since it's non-standard.
So get elements by ID, let's imagine it took 10 milliseconds. Would you see the JavaScript frame that makes the call to get elements by ID and the get elements by ID, or would it only be the JavaScript?
You would see both.
Okay.
Cool. Yeah. So, right. So, yeah, I think, Yoav, that does sound probably like what we want to do here, going with the WebDriver route. It's still kind of unfortunate that we can't test directly what we want to test, but I feel like most implementations are going to duplicate their implementations across like some sort of take sample and the actual sampling that occurs. Cool. So yeah, that sort of answers that. Going back to that point with callbacks, is that if we wanted to have like this manual take sample implementation, it would make testing that say performance done now is included in a trace very challenging, since there's no way to execute script obviously from these callbacks. Does anyone have any ideas for this? Because it's not necessarily a critical use case to test, but it's nice to have.
Yeah, we're out of time and I'm being kicked out, but yeah, the hardships of an office.
It sounds like we should maybe continue the discussion in the next call, Andrew.
Sure, yeah. No, this was pretty much all I had, so I think we're actually good.
Okay.
Yeah, let's solve this just with a tight loop test as a naive way to test the DOM callbacks are sampled.
Yep, so that's what we're doing with the web tests that we've written, but again, we're really worried about introducing flakiness, since that's something the VA guys have worried a lot about with their CPU profiler tests.
Andrew, just one cool thought. I keep thinking about the size of the payload.
Mm-hmm.
Not saying that this is something that you should adopt, but just mapping this to some of the work that we did in the reporting API. One of the things, so first of all, maybe a reporting API is something that this could leverage. And one of the primitives in there that we thought about is rate limiting. So the actual concern is it unbounded, and would it have undue impact on the user? So being able to reason about how much data, like putting a cap on how much data can be transferred. So for example, in reporting and network error logging, we have a policy of we will do at most one upload every 60 seconds, and that upload will be limited to a certain amount of bytes. So that way you can at least as a user reason about what the potential impact is of enabling such a feature. So maybe just something to explore in that area, if that makes sense in this context.
Yeah, no, I'll check that out for sure. Thanks. Cool. Thanks, everyone.
Okay. Thank you. And
thanks, folks.
Talk to you soon.
Thanks.
Thanks.
All right. See you.